Okay, congruent triangles review. I'm just going to go through each problem. It shouldn't be so bad. It should be pretty quick. It says state if the two triangles are congruent, mark any additional parts that are congruent, and state your reasoning for the congruence. So first thing I notice here is I look for things like vertical angles. So I mark these with 2. So I know that I have an angle, and a side here, an angle, and a side. So this has to be angle, angle, side, because the angles are not on each end of the side. For it to be angle, side, angle, you'd have to have another angle there. This next one, I know this side is congruent to this side. I know reflexive property, that is congruent, and I know this angle is congruent to this angle. So I look at this and I'm like, okay, well, here I have a side, an angle, and a side. So this one right here would be side, angle, side. But if I look at the second one, my angle in this case is not included. So this one right here is angle, side, side. Since these do not match, and angle, side, side is not a way to prove congruence, not congruent necessarily. They could be congruent, but not by any means. So this is all you would write. So anything that I box here is what you write. This next one, I know that I have these two angles. I know vertical angles are congruent. I know I have my side here and my side here. And so in this case, it will be side, angle, side. This next one, I notice that I have right angles, which may make a difference. I have this side here and this side here. And then by reflexive property, if I do it this way, this would actually be angle, side, side. And we know angle, side, side, or side, side, angle is not a way to prove congruence. But I notice that right here we have our right angle, which means it's a right triangle. And right triangles have one that only works for right triangles, and that's going to be hypotenuse leg theorem. And so what I look at, do I have a hypotenuse congruent? Well, yes, right here. My hypotenuse is congruent to my hypotenuse. And then right here, do I have two legs congruent? Yes, I do. So I have a hypotenuse and leg. So this is going to be hypotenuse leg theorem. This next one, reflexive property, and then I have two angles. In this case, the angles are on each end of the side, so angle, side, angle. This next one here, reflexive property, and this one's simply going to be side, side, side. For this next thing, it says, state what additional information is required in order to know the triangles are congruent. So for the first triangle here, we have two sides, we have an angle and an angle. Since they're not connected at all, there's nothing else I can conclude. And so this is looking for angle, angle, side. So in order for this to be angle, angle, side, I would have to know that angle A is congruent to angle R. So I'd have to know angle A is congruent to angle R. Otherwise, if you see the C and T, that would be angle, side, angle. And therefore, and it says write the congruent statement, something you need to know, I'm going to write triangle ABC is congruent to triangle. Well, A corresponds to R. B corresponds to S. Do that. B corresponds to S. And C corresponds to T, and so there's my congruent statement. This next one, to be side, angle, side, the angle has to be between the sides, so it would have to be angle U is congruent to angle H, and my congruent statement would be triangle TUV is congruent to triangle, while T is at the end with the double and so that's got to be is congruent to G. U is congruent to H, and I is congruent to V. So there we go. Those are our two parts. This next one, I know this angle and this angle are congruent because the vertical angles are congruent. That's not my additional piece of information. For this to be angle, side, angle, it has to be the side between the two angles that I know are congruent. So that's going to be TU is congruent to EU. Okay, that's my first piece of information. And then I write my congruent statement. If I write TUV, that's going to be congruent to triangle EUG. Because T is congruent to E, U is congruent to this U, or they're in the same place, and this V and this G are both congruent. This next one, I see that they have our right angles, reflexive property. And in order to use hypotenuse leg, you need to have a hypotenuse and you need to have a leg. My leg in this case is RQ. The hypotenuse of this first triangle is FQ, and the hypotenuse on the other side is RS. So I would have to know FQ is congruent to RS for it to be hypotenuse leg. And then we say triangle QRF is congruent to triangle, so QRF, then RQS, or thereabouts. The next one, I'm going to draw it out. It says given isosceles triangle ABC with vertex B. Well, if this is the vertex in an isosceles triangle, that means that this side and this side have to be congruent because those sides make up the vertex. It says the measure of angle B is 9x plus 4. It says the measure of angle A is 20x minus 10. Because of base angles theorem, I know that this angle also has to be 20x minus 10. And so once I realize that, I can say that all the angles add to 180, so 9x plus 4 plus 2, 20x minus 10 is equal to 180. 9x plus 4 plus 40x minus 20 is equal to 180. 49x minus 16 is equal to 180. 49x is equal to 196. X is equal to 4. It says find the measure of angle C. So the measure of angle C is going to be 20 times 4 minus 10, which is going to be 70 degrees. Number 12, I look at this, I don't always go in the order. I know that since these two sides are congruent, this angle is 70, this angle right here is 70, so I know the measure of angle 5 is equal to 70 degrees. I also know that the three angles in a triangle add to 180, so I know that that 70 plus 70 plus the measure of angle 1 is equal to 180. So the measure of angle 1 has to be 40 degrees. I'll put that up here. I know the angles in a triangle add to be 180, so I know 180 minus 107 minus 43 is going to give me 30 degrees, so the measure of angle 6 is equal to 30 degrees. I know angle 4 and the 107 here are linear pairs, so I know this is going to be 180 minus 107, which is equal to 73 degrees. I know all of these angles add to 180, so the measure of angle 2 is going to be 180 minus 65 minus 70, which is going to be 45 degrees. And then this measure of angle 3 here, I know that this angle plus this angle, and this is not the only way to do it, is the measure of angle 3, exterior angles theorem, so it's going to be 90 plus 45. So the measure of angle 3 is equal to 135 degrees. All right, so we have all of these here. Next one, number 13. Okay, it says find the measure of the sides and classify the triangle by its sides. So we find the distance for each one, the distance from A to B. It's going to be 1 minus 3 squared plus 5 minus negative 2 squared. Distance from A to B is going to be negative 2 squared plus 7 squared, 4 plus 49. Whew. Distance from A to B is equal to radical 53. Distance from B to C is going to be 3 minus negative 3 squared plus negative 2 minus 0 squared. Distance from B to C is going to be 6 squared plus negative 2 squared. Distance from B to C is going to be 36 plus 4. Distance from B to C is equal to radical 40. And last, the distance from A to C is equal to 1 minus negative 3 squared plus 5 minus 0 squared. From A to C is going to be 1 minus negative 3 is going to be 4 squared. 5 minus 0 is 5 squared. 16 plus 25. Distance from A to C is radical 41. So this is going to be, since none of the sides are the same, is a scalene triangle. Next one. It says ABF is isosceles, so I know that those angles would have to be the same. It says CDF is equilateral, which means that each of these angles is 60 degrees. It says AFD, so AFD, this whole angle here, is 150 degrees. And it says find a whole bunch of angles. So it says find the measure of angle CFD, which we already found is 60 degrees. It's an equilateral triangle. Measure of angle AFB. So AFB, this angle right here, well, I know that these add to 150, so it's going to be 150 minus 35 minus 60, which is 55 degrees. So that was that one. ABF, this angle right here, well, to find this angle right here, I know that the angle right there is also 50 degrees, or is also 55 degrees, excuse me. Do a different color. I know if this angle is 55, then this angle also has to be 55. So the measure of this angle up here is going to be 180 minus 55 minus 55. So the measure of angle ABF is going to be 70 degrees. And last but not least, the measure of angle A, we already have that, is 55 degrees. It says in triangle XYZ, the measure of Z, so I'm just going to write Z, not the measure of, is 2 more than twice the measure of X. The measure of angle Y, I'm just going to write Y, is 7 less than twice the measure of X. What is the measure of each angle? Well, the third thing we know is the measure of angle X plus the measure of angle Y plus the measure of angle Z is equal to 180. I cannot solve this because I have 3 variables. I want to get it down to 1, so it's going to be X. I'm going to replace this Y here with 2X minus 7. Okay. And this Z here, I'm going to replace it with 2X plus 2 equal to 180. So I go through X, 2X, and 2X. It's going to be 5X. Negative 7 plus 2 is negative 5 is equal to 180. 5X is equal to 185. X is equal to 37. And it says find the measure of each angle. The measure of angle X is equal to 37 degrees. Measure of angle Y is equal to 2 times 37 minus 7. So the measure of angle Y is 67 degrees. And the measure of angle Z is 2 times 37 plus 2, which is 76 degrees. Whew, tired. Number 16, what you have to remember is the sum of the remote interior angles. These always add to be the exterior angle. So I know 2x plus 110 is equal to 14x minus 10. I then solve. And x equals 10. It says to find the measure of EBC, so this angle here. So that's just going to be 14 times 10 minus 10, which is 130 degrees. Number 17 is determine if each of the following conditions are sufficient to prove the two triangles are congruent. If not, two sides of one and two sides of the other. Explain your reasoning. 2 parts is not sufficient. That's not enough information. 3 sides, that's actually going to be yes. 3 angles, this is no. They could be different sizes. Hoping you're not copying this, because if you have everything that I have written word for word, you guys should be writing it on your own. All 6, this is a yes. All sides are congruent. That's the first congruence criteria. 2 angles in the included side. So I draw a triangle. I have 2 angles in the included side and 2 sides in the included angle. This is going to be no, because there are different criteria. Two sides in a non-included angle. 2 sides in a non-included angle. No. This is angle side side. Is not a way to prove congruent. 2 angles in the non-included side. 2 angles in the non-included side of the other. This is a yes. This is angle, angle, side. 2 sides in the included angle. 2 sides in the included angle. This is a yes. 2 angles in an included side of one triangle are congruent to 2 angles. An included side for the other, so this is also going to be a yes. Okay, coordinate values of the vertices of K, L, M are integers. What set of coordinate pairs could be the vertices of a triangle? Things that you look for, you know that this side is 3, this side is 4. And from here to here, this is going to be, if you do distance formula, it's going to be the square root of 3 squared plus 4 squared, which is the square root of 9 plus 16, which is the square root of 25, which is equal to 5. So side LM, the distance was 3. Side KM, the distance was 4. Inside KL, the distance is 5. So that's what I'm looking for. I'm looking for a triangle that has those distances. And you can use either the graph or distance formula. So I have 0, 0. So the first one is 0, 0, 3, 4, and 0, 5. First thing I look at is I look at one of the distances. This is 1, 2, 3, 4, 5. So one side is 5. Okay, this side right here would be, that's going to be the square root of 1 squared plus 3 squared, which is equal to the square root of 10. That's going to be a no. Okay, so no. So this is a no. Next one. 0, 0, negative 5, 0, and 0, 0, 4. So this side is 4. So we have a side that's 4. this side right here is 5. Okay, which means this side right here would have to be 3. And so no, that one does not match. Go to the next one. -1, 1. -4. And -1, 5. And I look, this side is 3. This side is 4. Do my little Pythagorean magic. Okay, that's going to be the square root of 1, 2, 3, 4, 4 squared plus the square root of plus, and then this is going to be 1, 2, 3 plus 3 squared. It's going to be 16 plus 9, which is square root of 25, which is equal to 5, which we already have here. So this one is yes, or no, this one is all 3 sides are congruent. All right, last but not least, proof. I'm just going to go through this step by step. So the first statement is G is the midpoint of DF. To us. I can't mark anything congruent because I haven't said anything congruent, but if G is the midpoint, then I know DG must be congruent to GF. That is by definition of midpoint. So I'm going to mark this side and this side congruent. I then write my congruent statement. So DE is congruent to FE. Okay, and that's going to be, or DE is congruent to FE. That's given to us. So DE, FE. And then once I have that, I know EG is congruent to EG. That is reflexive property. And now I have 3 things. So I know triangle EGD is congruent to triangle EGF. I said side, side, congruent. Here. Next one, we're proving parts congruent. I don't know why my congruent symbols didn't come up here. Okay. So you have your statement. And you have your reason. So I know that CB is parallel to ED. That's given to me. If CB is parallel to ED, and you can do this, actually maybe you want to highlight it, I'll highlight these. So those are my parallel lines. So I look and see, do I have a transversal? Well, this right here is a transversal. So forget everything else besides those green lines. I know that this angle here is congruent to this angle here. I know that those are congruent by alternate interior angles theorem. So I know angle C must be congruent to angle D by alternate interior angles theorem. I also know, well, CB and ED, those are parallel to each other. I also know this is a transversal. And so I also know this angle and this angle are congruent. So I know angle B is congruent to angle E also by alternate interior angles theorem. And there's a couple different ways to do this, but this is the way that I prefer, also by alternate interior angles theorem. So I'm done with that. My next given is A is the midpoint of CD. That's given to me. What can I conclude from that? If A is the midpoint of CD, then I know AC and AD must be congruent. So AC is congruent to AD. Definition of midpoint. Okay. And I look to see I have 1, 2, 3 things that I've proven congruent. So I know I have enough information to say that triangle ABC is congruent to triangle. Now I'm careful. A is in the same place on both triangles. B was congruent to E, so that's got to be an E. And then D, and this is going to be by angle, side. Congruence theorem. Knowing that, if I know that those two triangles are congruent, I know that BA would have to be congruent to EA because corresponding parts of congruent triangles are congruent. And that's it. All right. 2 more proofs and 1 more thing. So, next thing, and we're not going to look at this, okay? My goal is to prove that the triangles are congruent, and then we can figure it out from there. So we have our statement, we have our reason. I'm just going to go through this step by step. So I know that AB is parallel to CD. That's given to us. Use my highlighter here. So I know that AB is parallel to CD. So first thing I look at is I look at this transversal. Unfortunately, this transversal, there's really no angles from our other triangle, so I actually can't use that. So I also realize that I have this transversal. I forget about everything else. And I say, okay, well, here, these would be alternate interior angles. Well, that's not going to be helpful because that angle is not part of anything. But I also know this angle and this angle are corresponding angles. And that is what we need. So I know that angle A is congruent to angle DCE because of corresponding angles postulate. Okay, I go to my next given, which is that BC is also parallel to DE. That's given. So BC is parallel to DE, so I look at this transversal, and I also see I have another pair of corresponding angles. I have angle E that must be congruent to angle BCA. That's also corresponding angles postulate. So I erase all of that because I want to make sure that I don't get confused. I see that I have another given, which is CD is congruent to AB. This is just missing it. So AB is congruent to CD. Okay, that's given to us. And so I have an angle on the side. That's sufficient amount of information to prove that they're congruent. So I know triangle ABC must be congruent to triangle CDE by angle, side. Now, that said, if I know that those are congruent, then I also know things like I know that AC would have to be congruent to CE because corresponding parts of congruent triangles are congruent. So I know that AC would be congruent to CE. That's CPCTC. If those two parts are congruent, then C must be a midpoint by the definition. So therefore, C is the midpoint of AE by definition of midpoint. And that's it. So we go through this one. You're given AB is congruent to CB. That's given. And the next thing is you're given DB bisects angle ABC. It's also given. If DB here bisects angle ABC, then I know this angle would have to be congruent to this angle, because that's how that works. That's what the term bisect means. So I know angle A, just be careful with you. If it's this angles, you have to write angles are congruent. I know angle ABD must be congruent to angle CBD. And I know that's the case by definition of bisect. Okay, so I have, right now I have 1, 2, I need a third thing. And I look, good old reflexive property, BD is congruent to BD. Reflexive property, which is great because then I can say triangle ABD is congruent to triangle CBD by side angle side. If the triangles are congruent, well, we're trying to prove that it bisects angle ADC. I know that this angle and this angle are the same. I know angle ADB is congruent to angle CDB. And that's because corresponding parts of congruent triangles are congruent. And last but not least, well then, if those two parts are congruent, then BD must bisect angle ADC by definition of bisect. And that was the fourth proof. All right, one more problem. Okay. So consider ABD and CDB, whose vertices are the coordinates. Well, A is 0, 0. So we have A here. We have B that's 2, 2, 4, 5. B is right here. C is 2, 9, 9, 5. Just make sure. 2, 4, 6, 8, 9, 3, 4, 5. So there's C, and D is 7, 0. Right here, 7, 0. So there is D. Oh, sorry for the technical difficulties. Okay. A is at 0, 0. B is at 2, 2, 4, 5. C is at 2, 4, 6, 8, 9, is right there, and then D is at 2, 4, 6, 7, right there. So we have two triangles here. And we're saying ABD, so we're going to draw this diagonal here. So now we have triangle ABD and BCD. And you need to explain why the triangles are congruent. So one of the first things that I see is I know BD is congruent to BD by reflexive property. I can count 1, 2, 3, 4, 5, 6, 7. I know the distance from B to C is equal to 7. 1, 2, 3, 4, 5, 6, 7. I also know the distance from A to D is also equal to 7. So BC must be congruent to AD because they have the same measure. Last but not least, I need to find these distances. Now, you can use distance formula and use the points, or you can use Pythagorean theorem. 1, 2, 3, 4, 5. So one side is 5, and the other side is 2. So I know the distance from A to B is going to be the square root of 5 squared, which is the distance between my y's, plus 2 squared, which is the distance between my x's. 25 plus 4, the distance from A to B is equal to radical 29. Here, same thing. I go 2 to the right and up. 1, 2, 3, 4, 5. So the distance from C to D is going to be equal to 5 squared plus 2 squared. Distance from C to D is 25 plus 4. Distance from C to D is radical 29. So since these both are equal to radical 29 by substitution, I know AB has to be congruent to CD. So what you've shown is you've shown 1, 2, all three sides are congruent. So the triangles are congruent. Okay. Last thing, make sure to correct any of your homework assignments. And come in for help the day before if you need to. Otherwise, good luck, and let me know if